Alright, so now we're going to be having a look at another question. This comes from a Uni Calc 1 course. Calc 1, this paper is from 2014. So here we have question 10. Question 10 here is about projections. So we need to first identify the definition of a projection vector. Right, so we have a formula for projections. We're going to have to use that here. You will have encountered it at some point if you are taking a calculus course where you are being tested on projection vectors. So we have projection of V onto W. V onto W is the wording, is equal to V dot product W over W dot product W multiplied by W. Now note this thing here, this fraction consisting of a dot product in the numerator and a dot product in the denominator, this is actually just a number. The two dot products will give numbers, so you get a fraction. You'll be multiplying the W vector by a fraction in order to get the projection of V onto W. And this makes sense because the projection onto W must go in the same direction as W, but it's not necessarily the same length. So if you have one vector here and one vector here, and let's say this one is W and this one is V, if you're trying to find the projection of V onto W, that means the vector you get when you directly cast a shadow down here, that's essentially this vector. This is the projection, points in the same direction as W. It's actually overlaps with W. I've just drawn it to show more clearly what it is. I could use a different color here to do this. In fact, the projection vector will be this vector. This will be projection of V onto W. So we need to use some dot products and some multiplication, and this is going to get us our solution. So here we know W is the vector 2, 2, 1. V is the vector 3, 0, minus 4. So we first need to do V dot W. So V is 3, 0, minus 4, dot 2, 2, 1. This is of course dot products, not multiplications. So multiply piecewise and add. So 3 times 2 plus 0 times 2 plus minus 4 times 1. So 6 plus 0 minus 4 is 2. So the dot product of V and W is 2. Now the dot product of W and W, this is 2, 2, 1, dot 2, 2, 1. Sometimes people give these special names. You don't have to. It's just a dot product of W with itself. 2 times 2 is our first term, plus 2 times 2 is our second term, plus 1 times 1 is our third term. 2 times 2 is 4. 4 plus 4 plus 1 is 9. So this means the projection of 3, 0, minus 4 onto 2, 2, 1 is going to be equal to V dot W over W dot W. So V dot W is 2 over 9 multiplied by the vector W, which in this case is 2, 2, 1. So if we expand this through, this gives us 4 on 9, 4 on 9, 2 on 9. And if we leave it factorized, it's just 2 on 9 times 2, 2, 1. Now you'll notice of the answers here, none of them are 4 on 9, 4 on 9, 2 on 9. None of them are 2 on 9 times 2, 2, 1. And in fact, the answer to this question is E. It's not uncommon once you get to, so for any students watching, high school students or introductory calculus students, Calc 1 students at university watching, it's not uncommon once you get to the university level for the multiple choice questions to go from being 3 or 4 options to being 5 or 6 options, where some of the options will be A, there is no answer, B, the answer is too difficult to calculate manually. These are possible answers to questions. So even though this is multiple choice, these can be a little difficult. You have to do the projection, identify that the projection is not in the list, and therefore deduce that the answer is none of the above. And this is in fact the correct answer.